Hi y'all, welcome to your Unit 4 test review. This video will be numbers 1 through 15, and then a second video will have the, pardon me, a second video will have the others. First off, the days of the week on this are wrong, sorry. Wednesday, November 15th, and Thursday, November 16th, are when those tests are actually happening. So, solve for X. We're going to solve like we are not using a calculator. You will have a no calculator section on your test. So, here for number 1, we need to make the bases here the same. So 27 can be written as 3 to a power. So we will leave that left side alone. 3 to the power of 2x minus 1. And that's equal to 27 is 3 to the power of 3. And now that the bases are equal, we know that the exponents have to be equal. So 2x minus 1 must equal 3. 2x would equal 4. And x equals 2 is our final answer. Let's go to number 2. Again, we want the same base. They both 3 and 1/3 can be written as powers of 3. So we'll leave 3 to the x alone. We'll take that 1/3. It's still to the x minus 3 power, but 1 over 3 to the first can be written as 3 to the negative 1. And now the bases are the same. So 3 to the x would equal 3 to the power of, we multiply when we raise a power to a power, so that will be negative x plus 3. And then here the exponents must be equal because now the bases are equal. So x will equal negative x plus 3. Add the x over. 2x equals 3. Divide off the 2. X is 3 over 2. And yes, that improper fraction is a perfectly acceptable answer. So let's look at 3. Our variable here in 3 is the base of the log. Excuse me, to undo that, we'll drop and cross. So we'll have x, drop the base, to the power 4, equaling 7. Now, we need to get that x by itself. If that were an x square, we would take the square root. So here, we take the 4th root. So the 4th root of 7 is one way to write this. Another way to write that is 7 to the power of 1 over 4. Both of those are equivalent. Both of those would be correct. Either one of those could be a correct multiple choice. Remember, when we convert the radical to an exponent that's a fraction, the number that is the power goes on top, just like flowers are on top of plants, and there is a root on the bottom. So let's look at 4. We have log base 64 of 16 equaling x. I'm going to drop and cross this to get this into a good form. So 64 to the power of x will equal 16. Now, we want the same base on each side. And 64 and 16 are both powers of 4. 64 is 4 to the power of 3. 16 is 4 to the power of 2. So on the left, we raise a power to a power. That's 4 to the power of 3x, equaling 4 to the power of 2. And now the exponents here must be equal. So 3x must equal 2. Divide off the 3, and x is 2 over 3. Again, feel free to leave it as that fraction. So let's look at 5. We are looking for what is equivalent to 2 to the power of 3 minus 5x. So what we want to do is convert each of these expressions into having a base of 2. So 1 over 8, we know that 2 to the third is 8. So 2 to the negative third would be 1 over 8. So if I write this as 2 to the negative third to the negative 5x, raising a power to a power multiplies. That's 2 to the power of 15x, which is not equivalent to what I needed. So answer A is not it. Answer B, again, we need to convert to a base of 2 because that's what our equivalent is. X minus 3 over 5 is that power. Instead of 1 over 8, we'll write that as 2 to the negative 3. Again, we raise a power to a power by multiplying the exponents. So that's 2 to the power of negative 3x, and then that'll be plus 9 over 5. It's not what we needed, so answer B is out. Let's look at C. We have a base of 1/2. We want that base to be a base of 2. 1/2 is 2 to the negative 1. Negative exponent flips, so 2 to the negative 1 will flip to 1 over 2. And this equals 2 to the power of negative 5x plus 3. And that truly is equal because negative 5x plus 3 is the same as positive 3 minus 5x. So answer choice C here is the one that is equivalent. All right, let's look at number 6. We are solving for x, and we are simplifying fractions as needed. So we have a base that's a square root of 9 and a base that's a 1 over 81. So both of those can be converted into powers of 9. So on the left, we'll have something to the 5x minus 1. On the right, we'll have something to the x minus 4. Square root of 9 is the same as 9 to the 1/2 power. There's a understood 2 on the root. There's a power of 1. Power on top, that's the 1. Root on the bottom, that's the 2. 81, 1 over 81 will be 9 to the negative 2. That negative 2 flips the 9 to the positive 2 to be 1 over 81. Now, raising a power to a power, we multiply our exponents. So 9 to the power of 5 over 2 minus 1/2 equals 9 to the power of negative 2x plus 8. I dropped an x in there. So then our exponents must be equal. So 5 over 2x minus 1/2 is equal to negative 2x plus 8. I don't like that fraction. You probably don't either. We can get rid of that fraction. We can multiply both sides of the equation by 2, and that will clear the fraction. We'll have 5x minus 1 on the left, and we'll have negative 4x plus 16 on the right. So then when we add the 4x over, we get 9x, Add the 1 over, we get 17, and x is 17 over 9. That feels a little weird to have that kind of fraction as an answer, but it's what the answer is. Let's look at 7. We have a bunch of stuff going on here on the left. We have on the right, on the right, we have multiple logs. We want to condense those into a single log. So log of x will equal, when we condense into a single log, coefficients become exponents. So we'll have log of 64 to the 1/3 power minus log of 32 to the 1/5 power. Okay. Now, we need to look at what to the 3rd power is 64. 4 to the 3rd is 64. What to the 5th is 32, and that is 2. 2 to the 5th is 32. So this becomes the log of 4 minus the log of 2. And 64 to the 1/3 is 4, because 4 to the 3rd is 64. 32 to the 1/5 power is 2, because 2 to the 5th power is 32. Now, we have two logs, separate logs that are being subtracted. When we condense those, we divide. So log of 4 over 2, that equals log of 2. So that whole right side simplified to log of 2. Log of x equals log of 2, so x is 2. And let's keep going. Let's look at 8. With the variable in the base, we want to drop and cross. So that will be x to the -3 equaling 64. A negative power flips, so that's 1 over x to the 3rd equaling 64. Then multiply both sides by x to the 3rd to get that out of the denominator. So 1 is 64 x to the 3rd. We want the x term by itself, so we'll divide by 64. So then x to the 3rd is 1 over 64. So to undo that 3rd power, we do the 3rd root, or cube root. That's an equal sign. So we'll do the cube root of 1 over 64, which would be the cube root of 1 over the cube root of 64. So any root of 1 is always 1 over the cube root of 64 is 4, because 4 to the 3rd is 64. So the cube root of 64 is 4, and x here is 1/4. On number 9, start with drop and cross. And we'll have x to the power of 1/8 equals the 4th root of 13. We can take that 4th root of 13, rewrite it as 13 to the power of 1 over 4. And then to undo a 1/8 power, we want to raise to the 8th power, which means we're multiplying a power to a power. So that ends up x on the left equal to 13 to the 8 over 4, which is 13 to the second power. So x is 13 squared, or 169. Let's go to 10. Looks like a lot. It's going to be just fine, I promise. On the right-hand side, take this 2, make it a power. And on this left side, condense this into a single log. So, would be log base 4 of x minus 4 times x plus 4. And that would be equal to log base 4 of 3 squared. So 3 squared is 9. It's going to be log base 4 of 9. When we multiply out x plus 4 times x minus 4, those middle terms zero themselves out, and we're left with x squared minus 16. So log base 4 of x squared minus 16 equals log base 4 of 9. So what's inside the logs must be equal. X squared minus 16 is equal to 9. So x squared equals 25. Take the square root, and x equals 5. Don't forget the plus or minus sign on that 5. So would that work? Does those stay positive? No, it is just the positive. We cannot put a negative number inside a log, and if we use a negative 5 here, we'll have a negative inside a log. So only the positive 5 here counts. Let's look at 11, and we'll want to condense again. We'll want to condense this left side. So we will have log base 2 of the 2 logs added, condense as 1 log multiplied. It's going to equal 4. So that will be log base 2 of x squared minus 6x equal to 4. From here, drop and cross, convert to exponent form, drop the base 2 to the power of 4 equals x squared minus 6x. 2 to the power of 4 is 16. Scoot this over because I'm going to want some room. Okay, I'm going to try one more time to scoot this over. Oh, it heard me that time. So, 2 to the 4th power is 16. 16 equals x squared minus 6x. This is quadratic, so to solve this, we want one side equal to 0. So x squared minus 6x minus 16 is equal to 0. To solve that, we want to look for magic numbers. They'll need to multiply to be negative 16 and add up to be negative 6. It's going to be a 2 and an 8, a positive 2 and negative 8. So this factors as x plus 2 times x minus 8 equal to 0. So x would equal negative 2, or x would equal positive 8. We cannot put a negative 2, a negative anything, into a log. Its domain is only from 0 to infinity. So we cannot use negative 2 as a solution, but this 8 is a solution. Let's take a look at 12. We have 49 to the power of negative log base 7 of 4. And that's going to equal something. What we need here is the base of the log and the base of the exponent to be the same. So we take that 49. It's still to the power of negative log base 7 of 4. We write that 49 as 7 squared. Now, once we simplify with that exponent, that base of the log and base of the exponent will be the same value. So this becomes 7 to the power of negative 2 log base 7 of 4. That negative 2 coefficient in front of a log becomes an exponent. So that is 7 to the power of log base 7 of 4 to the negative 2. 7 to the power of log base 7 is going to equal 4 to the power of negative 2, which is 1 over 4 to the power of positive 2, which is 1 over 16. So 1 over 16 is that final answer. This 7 to the power of and log base 7 undo each other, leaving us with just that 4 to the negative 2. On 13, we want to simplify this big yucky exponent. We're going to take that 3, make it a power. We're going to take this 2, make it a power. So 6 to the power of log base 6 of 2 to the third plus log base 6 of 3 squared. So that's 6 to the power of log base 6 of 8 plus log base 6 of 9. All of that is in the exponent. To condense those, there are 2 logs that are added. So we will multiply what's inside them, and that is still 6 to the power of log base 6 of 8 times 9. So 6 to the power of log base 6 of 72. This 6 to the power of and this log base 6 undo each other, and this is equal to 72. And there's our final answer. Let's look at 14. We are finding the value of all of this stuff. Work from the inside out. Do the inside first. So log base 2 of 16 will equal something. That means 2 to some power is 16. And we know that that power would have to be 4. So log base 2 of 16 is replaced with 4. Now, do the next piece. Log base 2 of 4 equals something, which means 2 to some power is 4. We know that 2 squared is 4. So log base 2 of 4 is 2. So we replace this whole thing with the value 2. And now we're doing the very last step, this whole thing, which is log base 2 of 2. Meaning 2 to some power is 2. We know that power is 1. So our final answer here is 1. Work out what the innermost value is. Replace the log with its value. Repeat for the middle piece. Repeat for the final outside piece. Let's go to 15. Similar problem. Work the inner function first. Log base 3 of 9 equals something. So 3 to some power is 9. It's going to be 3 squared. So log base 3 of 9 equals 2. Then do the middle piece. Log base 2 of 2 equals something. So 2 to some power equals 2. That value is 1. 2 to the first equals 2. So this log gets replaced with 1. And now we're doing that final piece, outer piece, just log base 16 of 1 equaling what will be our final answer. So 16 to some power equals 1. Well, the only way to get 16 to a power to be 1 is to use 0. So that final answer here is 0. All right, that's it for 1 through 15. Stay tuned for the second half in just a